Hi everyone, Assalamualaikum. In this section, we will discuss applications of differentiation under optimization using second derivative test. Okay. Now we look at example 1 from previous semester papers. Okay. A rectangular door with a semicircular top as shown in figure below is to have a perimeter of 6 meter. Okay. This is the given diagram. Okay. Number 1, express y in terms of x. Number 2, show that the area of the door is given by a equals to 24x minus 4x squared minus pi x squared over 8. And number 3, determine the maximum area of the door. Okay. Alright, from the given question, number 1, express y in terms of x. Okay. First step, we draw an appropriate diagrams and label an appropriate quantities. Alright, this is the given diagram. And then step 2, equate an appropriate formula to the given value. Write y as a subject and name it as equation 1. Okay. We are given perimeter equals to 6 meters. Okay. So from here, this is arc length of semicircle. Okay. Let's say we denote as S. Alright. Okay. S equals to half times perimeter of one circle. Right. And S equals to half times 2 pi r. Okay. Perimeter of circle equals to 2 pi r. Then we can simplify 2. Okay. Then we can write S equals to pi r. Right. And this is r. Okay, radius of semicircle. Okay, or radius of circle. Okay, we can write r equals to x over 2 because the diameter of the circle equals to x. Okay, from here. Okay. Right, then we get s equals to pi. We replace r equals to x over 2. Okay, from here. Right. Then we can rewrite s equals to pi x over 2. Right? And then we refer back from perimeter equals to 6 meter. Okay. So perimeter equals to x plus y plus s plus y equals to 6. Okay, from here x, y, s, and y here. Okay. And then we can replace s equals to pi x over 2. Okay, from here. Alright. And then we can write 2y equals to 6 minus x minus pi over 2. Pi x over 2. Okay. We simplify, so we have y plus y here. So we get 2y. And then we move x and pi x over 2 to the right hand side. Alright. Then we can write y equals to half times 6 minus x minus pi x over 2. Then we expand 1 by 1. Then we get y equals to 3 minus half x minus pi over 4x. Right? This is y in terms of x. Okay? So this is the answer. Right? And we can name it as equation 1. Okay? To solve the next question. Alright? Alright, from number 1, we get the answer y equals to 3 minus half x minus pi over 4 x, which is y in terms of x. Alright? Now we continue with number 2. Show that area of the door is given by A equals to 24x minus 4x squared minus pi x squared over 8, right? Right, so we continue with step 3. Okay, write another relevant formula, naming it as equation 2. Okay, this is two-dimensional diagram, right? So another relevant formula is area. Okay, alright, the area of the door, okay, equals to area of rectangle plus area of semicircle. Alright, so we can write A equals to xy plus half pi r squared. Okay, this comes from area of rectangle here equals to x times y, which is xy. Alright, area of semicircle, okay, from here, okay, equals to half pi r squared. Alright, and then we replace r equals to x over 2. This comes from the previous slide. Okay, r equals to x over 2 because the diameter of circle equals to x. So radius equals to x divided by 2. Alright, so we replace here. Right, because we want in terms area in terms of x. Alright. Alright, and then we expand squared here. So we get A equals to xy plus pi over 2 times x squared over 4. Alright. And we simplify, so we get A equals to xy plus pi x squared over 8. Alright. Then we name as equation 2. Right? After we write another relevant formula, naming it as equation 2. Alright? And then we continue with step 4. Okay? Substitute equation 1 into equation 2. Okay? So we get A equals to x times 3 minus half x minus pi over 4x plus pi over 8x squared. Okay? Y here, okay, we replace with equation 1 that we get from the previous slide. Okay, 3 minus half x minus pi over 4x. Okay, this comes from equation 1 from the previous slide. Okay, and then plus pi 8x squared. Okay, we substitute equation 1 into equation 2 because we want to write area in terms of variable x only. Okay, from equation 2, we get area in terms of variable x and y. So when we substitute equation 1 from the previous slide into equation 2 here, we will get area in terms of variable x only. Alright. Then we expand x and bracket, so we get A equals to 3x minus half x squared minus pi over 4x squared plus pi 8x squared. Okay. Then we can standardize the denominators. Okay. So we get for 3x we can write 24x over 8 minus, okay, for half x squared we can write 4x squared over 8, and then for pi over 4x squared we can write 2 pi x squared over 8, and then plus pi x squared over 8. Okay, so all denominators are equal, right? So we can join it. Okay, so we can write 24x minus 4x minus 2 pi x squared plus pi x squared over 8. Okay, then we have term containing x squared here. Okay, and have pi here. So we can simplify negative 2 pi and plus pi. Okay, so we will get 24x minus 4x squared, negative 2 plus 1 pi, so equals to negative pi x squared over 8. Okay, Then we compare, okay, with the given question. Okay, it is exactly the same. Alright, so it is shown. Alright. Alright, now we continue with number 3. Determine the maximum area of the door. Okay. From number 2, we get A equals to 24 minus 4x squared minus pi x squared over 8. Okay. So to determine the maximum area, first we need to find dA over dx. Okay. dA over dx means we differentiate A with respect to x. Okay. So to differentiate this equation, okay, we can separate first. Okay. So we separate the denominator, then we simplify, so we get 3x minus half x squared minus pi over 8 x squared. Alright. Then we can differentiate. Okay, so we differentiate A with respect to x, so we get dA over dx. We differentiate 3x, we get 3. We just differentiate one by one because in between is minus. So we differentiate using sum and difference rule. Alright, and then minus, and then we have constant here, so we still put the constant. Then we differentiate x squared using power rule, so we get 2x. Okay, and then minus constant pi over 8. Okay, and then we differentiate x squared, so we get 2x. Alright, then we can simplify 2 and 2 here, and we can simplify 2 and 8 here, so we get denominator 4. Okay, then we can write dA over dx equals to 3 minus x minus pi over 4x, right? Okay, then step 2, when dA over dx equal to 0, we need to find the value of x. Okay, so from dA over dx equals to 3 minus x minus pi over 4x, we equate to 0. Okay, then we need to find the value of x. Okay, so we can move term containing x to right hand side, so we get this. Then we can factorize x, so we get 3 equals to x in bracket 1 plus pi over 4. Then we get x equals to, we move 1 plus pi over 4 to left hand side, so we get 3 over 1 plus pi over 4. Okay, then we can use calculator to solve. So we get x equals to 1.68. Okay, from the given question, okay, the unit used is meter. So we can write x equals to 1 over 68 meter. Alright. Alright. We're still under question 3. Determine the maximum area of the door. From the previous slide, we get x equals to 1.68 meter. Okay. Then we can continue with step 3. Alright. Find d2a over dx2. Okay. To find d2a over dx2, we need to differentiate from the first derivative, dA over dx equals to 3 minus x minus pi over 4x that we get in the previous slide, right? Then we can differentiate. Okay? We just differentiate one by one because in between is minus sign. So we differentiate first derivative dA over dx, so we get second derivative d2a over dx2 equals to, we differentiate 3, it is equals to 0. Then we differentiate negative x, we get negative 1 minus, differentiate pi over 4x, we get pi over 4 and minus sign here. Okay. So when we solve, okay, this is negative value. Okay, or in other words, less than 0. Okay, so when second derivative has negative value, okay, negative means we will get set. Okay, and At the same time, set means maximum. Okay, the graph is maximum. Alright. So therefore, x equals to 1.6 meter will maximize the area. Alright, because we differentiate area. Okay. Okay. We recall back the question. Determine the maximum area of the door. Okay. So we're not finished yet the question. Okay. So we continue with step 4. Okay. To find the maximum area, replace the x value in the area formula. Alright. So from the area formula in number 2, okay, we get A equals to 24x minus 4x squared minus pi x squared over 8. Okay. Then we substitute x equals to 1.6 meter. That will maximize the area. Okay. Then we can solve using calculator. So we get maximum area equals to, after we solve this, okay, equals to 2.52. Okay. And the unit given is meter. So for area, we can write meter and then square. Alright. So this is the maximum area. When we substitute x equals to 1.68 meter, that will maximize the area. Okay. Coming up next, more examples involving optimization. Thank you for watching. Stay tuned. Bye. Assalamualaikum.